Before we actually start doing some equilibrium problems of particles in 3 dimensions, I realize there's some components within the problem that we haven't learned yet. So we're going to talk about the idea of reaction forces of mechanical components. And we're going to go through all of them. Some of the stuff we're going to explain, we're going to talk about in this video, we haven't explained, such as the idea of moments. So we're going to start off with the first one, and that is called a fixed support. And what it is, we basically have something stationary, inertial reference frame, and we have a beam or a fixed support right here. And basically, if there's a force being applied to it, let's say downward, there has to be a reaction force because we know this beam is in equilibrium. So wherever the force equals, or wherever the force is being faced, we could say F. That means there's a reaction force over here or over there that is being applied so that it doesn't move downward. Or if the force going upward is going upward, then there's a reaction force going downward. So in a general sense, I'm just going to define the reaction forces in one way, and you could apply it how you like. So there's a reaction force going this way, so we say Fy. And then there's also a reaction force going that way because we know the beam cannot move to the left or to the right. So we're going to say there's a reaction force going that way. And this is the part I was talking about that we haven't learned yet, but there's this idea of a moment. So if there was a force being applied over here at a distance from this so-called pivot, there won't be any need for rotation because this is a fixed support. It doesn't rotate. So there's also a moment occurring on this support. So that is a reaction force of a rotation. So in essence, there's two components. There's a reaction force in the x direction and the y direction, and then there's a moment being applied as well to prevent rotation. So the next thing we're going to look at is a pin support. So a pin support. Alright, so what we're going to do, we're going to draw a pin. So that's not a straight line. So this is a pin going like this, and then there's maybe like a rod or something that is connected to it, and we have it going like that. That is not a good drawing, so something like that. I don't know. And then there's a pin right there. So what we're gonna do, we're gonna isolate this this rod from the pin. So we're gonna have something that looks like this. And what we're gonna do, we're gonna apply the idea of reaction forces. So this pin actually allows us to rotate the rod. However, it cannot translate, so it cannot move in any direction. So that's why we apply reaction forces in the y direction and the reaction forces in the x direction. So there's no moment on this support or this pin support because this rod can freely rotate around this pivot. Another component we're going to look at is called a roller support, or just roller. I don't know. You could call it whatever you want. But the idea is that we have some wheel basically, and it's being applied. There's one applied force onto it. So let's say this is connected to a pin, and this is on the ground. So the only reaction force being applied here is this roller support can move. It can move this way and that way. However, it will stay on the ground. So the only reaction force is the contact between the roller and the surface. So what we can do is isolate the roller. So we have that, and then the reaction force acting on it will be something like this, the normal force. Now what's important to note is that a roller could be applied on any surface. So we could draw the surface at actually a different angle, so we could have that, and then this roller right here could be something like that, and the reaction force will actually be in this direction. So if this was theta, then this would be the angle at which the normal force interacts with the roller. So that is very important to know. So the next thing we're looking at is a slider or constrained pin. So basically this whole component is what we're looking at. So this thing is free to slide in this direction, and this pin is free to rotate. So the only thing that's being applied is this idea of a normal force. And the normal force is basically the point at which the pin is pointing. So we could say that we have this over here, and this is the pin. So we could say that the reaction force is strictly in the direction of the rod. The next thing we're going to look at is a translational guide. So translational guide, and we're going to look at that. So this is what it looks like. We have, some guide, but it's constrained. So we have that. I can't draw this correctly. So we have this. Just imagine these walls were touching, and we're gonna draw something that sticks out from it. So this is the translational guide, and basically the only forces acting on this body, so we could draw it over here, is that this thing cannot rotate, and it can and the only force being applied to it is this normal force that it has contact with. So there's a normal force going this way, and there's a moment going this way. So now we have a contact with a smooth surface. So what we can do is draw a smooth surface. There's no friction, so to speak. You could draw a straight line, and then maybe some sort of rod that points in this direction. So if we isolate, or not isolate, but we could just do it in this one picture, the only force that acts upon it is the normal force. And again, this idea that the surface itself can be at an angle. So what we can draw here is that, and let's say that this is being applied in this direction. So there's that rod once again, and the normal force is perpendicular to the surface. So if this was theta and the normal force was being applied such that it points in that direction, then this angle right here is theta. The next thing I want to talk about are springs and how they work in terms of forces. So a spring is usually drawn something like this, maybe like a resistor in electrical engineering, but the idea is that, so we have a force, or it's attached to some sort of wall, and there's a force being applied in this direction. So let's say we have a box that is moving in this direction. So the box is moving at some velocity in that direction. What is interesting about a spring is that it's a force that points in the opposite direction of motion. So if we isolate the spring, it's like a cable or a tension. So what we can do is isolate the spring and apply the idea of the force on it. So what actually happens is that the force points inward because it's moving since the box is moving in this direction. If the box was moving going to the left, this force S would be pointing in the opposite direction. And another thing that we kind of hint on before in a previous problem is the idea of gravity. So if we have a body or some sort of particle, but we're going to generalize it by using a rigid body, gravitational force. So we could have an arbitrary shape, and the gravitational force always acts at the point of center of mass. So the center of mass is calculated in a way that we'll discuss later, but is usually denoted in this fashion. So it's a circle, there's a cross that goes through it, if I could draw this properly, and this is usually shaded in, and this is usually shaded in. And this is called the center of gravity. and gravity always points downward. So this is the way we would draw it. So if this is the center of gravity, then the force of gravity would point that way. And as we said before, the force of gravity, which I say the weight, is the mass times the force, or times the acceleration of gravity, which is similar to the force equals mass times acceleration. So that is very important to know, that some objects have a center of gravity that is not directly in the center of the object, or not symmetrically centered. So keep that in mind when solving problems. So these are all the reaction forces of various components in statics, and some of these are intuitive, some of these are not. So just have these in mind when you solve problems. One of the most common ones are pin supports and roller supports, and just keep those in mind when solving problems once again.